Hello, my dear friends, and welcome to our today's class. It's our 8th lesson on the 5th topic of Form 3 work, which is called Current Electricity 2. As usual, let me commence by giving you the quote of the day, which states that the willingness to do something ends up creating the ability to do that particular thing. We shall discuss that quote at the end of our class today. So today we are looking at further examples involving calculations on current electricity 2. So our first example reads that study the circuit diagram below and use it to answer the questions that follows. Then, so this is the circuit diagram. Then we are required to determine part A, the effective resistance, which is worth 3 marks. So the key things that you need to note when performing calculations involving current electricity 2, first of all, you need to note this small table here, that whenever resistors are connected in series, then the total current entering a junction must be equal to the current drop through each of the resistors. Then the voltage drop across each resistor must be equal to the sum. That is, the total voltage must be equal to the sum of the voltage drops across each resistor in that series connection. Then total resistance, R total, is equals to the sum of the resistances. That is the resistors in each of the resistors connected in series. Then in parallel connection, total current must be equal to the sum of the current drop across each resistor. Total voltage must be equal to the voltage across each component. Then the reciprocal of the effective resistance or total resistance must be equal to the sum of the resistances of the individual resistors. Then you also remember the Ohm's law, that voltage is equal to the product of current and the resistance. So part A, they want us to find the effective resistance. Remember, we did say from our previous classes that effective resistance simply means total resistance or the equivalent resistance through that particular circuit. So then we also said that to find the effective resistance or total resistance, we first of all start by breaking our circuit in such a way that we end up with a circuit that of resistors which are in series, such as the one shown here. So we'll start by breaking this particular part until we end up with a circuit that is in series. So the first thing, let's observe the 4 ohm resistor and the 1 ohm resistor. So these two resistors, we want to combine them into one resistor. So you can see 4 ohm resistor is connected along a 1 ohm resistor. Therefore, this is series connection of resistors. However, a combination of 4 ohm resistor and a combination of 2 and 3 ohm resistor will be in parallel with the first resistors. So because 4 ohm resistor and 1 ohm resistor are in series, we said that for any series connection, the total resistance is equal to the sum of the resistance drops at each point. Therefore, we'll combine the 4 and the 1 ohm resistor. So resistance through the 4 and 1 ohm resistor will just be the sum of the resistance through the 4 ohm resistor and the resistance through the 1 ohm resistor. So we are adding because 4 and 1 ohm resistor are in series with each other. Therefore, for series connection, R total is equal to R1 plus R2. Therefore, R through the 4 ohm resistor plus R through the 1 ohm resistor, which gives us 4 ohm plus 1 ohm, which gives us 5 ohm. Remember, S stands for series connection. Then we'll also combine the 2 and 3 ohm resistor so that they form one resistor or one common resistor. Again, 2 and 3 ohm resistor are connected along each other. Therefore, they are in series with each other. And for series connection, R total is equal to R1 plus R2. Therefore, the resistance through the 2 ohm and 3 ohm will simply be R through the 2 ohm plus resistance through the 3 ohm, which is just resistance through the 2 ohm is of course 2 ohm, plus resistance through the 3 ohm resistor is 3 ohm. Therefore, 2 plus 3 will simply get 5 ohm resistance. Therefore, now our circuit will break into, so 4 and 5, that is 4 ohm resistor and 1 ohm resistor have given us a combination of 5 ohm resistor, also a 2 ohm resistor and a 3 ohm resistor. They have given us a combination of 5 ohm resistor. Therefore, our circuit will break down into this format. So this is now our new resistor, that is our new circuit. So remember, 5 ohm is the combination of 4 and 1. Then the other 5 ohm is a combination of 2 and 3 ohm resistor. So now from this arrangement, you can see that the 5 ohm resistor and the 5 ohm resistor, they are connected across each other. Therefore, they are said to be in parallel connection. Therefore, we shall combine this one until we end up with a total resistance which is in series. So we'll combine the 5 ohm resistor and the 5 ohm resistor to obtain one common resistor. So because 5 ohm and 5 ohm are connected in parallel, and we said that for parallel connection, the reciprocal of the effective resistance or total resistance is equals to the sum of the reciprocals of the other individual resistors. Therefore, R effective for 5 and 5 ohm resistor, so resistance through the 5 and 5 ohm resistor, so 1 over R through the 5 and 5 ohm resistor will be equal to 1 over R through the 5 ohm plus 1 over R through the 5 ohm. So we are using this formula because the 5 ohm and the 5 ohm resistor, they are connected in parallel. And of course, in parallel, we said that the reciprocal of the effective resistance is equals to the sum of the reciprocals of the individual resistances. Therefore, 1 over R through 5 and 5 ohm resistor will be 1 over resistance through the 5 ohm resistor, of course, is 5, plus the resistance through the 5 ohm resistor is also 5. Therefore, 1 over R through the 5 ohm and 5 ohm resistor will be 1 over 5 plus 1 over 5, which gives us 2 over 5. So to find the resistance through the 5 and 5 ohm resistor, we'll simply take reciprocals on both sides. Therefore, reciprocal of 1 over R through the 5 and 5 ohm resistor, its reciprocal will just be R resistance through the 5 and 5 ohm resistor. That is, we are taking 1 divided by 1 over R through the 5 and 5 ohm resistor. So that will give us, the reciprocal will give us resistance through the 5 and 5 ohm resistor, which is equals to, we also take reciprocals on the right hand side. So the reciprocal of 2 over 5 will of course be 5 over 2. So 5 divided by 2 will get 2.5 ohm. So this is the total resistance, that is for the two resistors which are in parallel. So this is the combined resistance of the 5 and 5 ohm resistors. Now we can represent the 5 and 5 ohm resistor by just one resistor, which is the 2.5 ohm resistor. So a combination of 5 and 5 will give us a 2.5 ohm resistor. Therefore, our final circuit will just be, remember our initial, we had 5.5 ohm resistor, which is here. Then a combination of 5 and 5 has given us 2.5. Therefore, 2.5 is just a combination of these two resistors. Therefore, this will be our final resistor. So the aim here, first of all, is just to break down the circuit in such a way that you end up with resistors which are in series, the way we have broken down this circuit here. So now, once we have the 2.5 ohm resistor and the 5.5 ohm resistor, you can clearly see that they are connected along each other, or they are in series with each other. And you have said that for any series connection, R total must be equal to R1 plus R2. That is the sum of the individual resistances. Therefore, R effective through the circuit will just take resistance through the 2.5 ohm resistor because it is in series with the 5.5 ohm resistor plus the resistance through the 5.5 ohm resistor. So this will be equal to resistance through 2.5 is just 2.5 ohm plus the resistance through 5.5 ohm is just 5.5 ohm. So again, we are adding because it is series connection. So S stands for series connection, but P stands for parallel connection. So 2.5 plus 5.5, you'll simply get an effective or a total resistance of the circuit as 8 ohm. So that is the effective resistance through the circuit. It is 8 ohm. Then part B, they want us to find the current through the 5.5 ohm resistor. So remember that the 5.5 ohm resistor from this initial diagram, it was in series with the battery, or it was in series with our source of power. And we have said that for any series connection, I total must be equal to I1 must be equal to I2. That is, the current is the same for the series connection. The current is equal to that of the source. So if you want to find the current through the 5.5 ohm resistor, from Ohm's law, for you to find current, you need the voltage and you also need the resistance. Of course, we already have the resistance of the 5.5 ohm resistor, which is just 5.5. So our task is just to find the voltage through the 5.5 ohm resistor. But we know that the current through the 5.5 ohm resistor must be equal to the total current. The reason being, the 5.5 ohm resistor was initially in series with the battery or the source of power. Therefore, the total current or the effective, the total current through the circuit must be equal to the current through the 5.5 ohm resistor, because they were initially in series connection. So you can see that I total for series connection is equals to I1 is equals to I2. So if we find the current of the source, or the current through the whole circuit, that must be equal to the current through the 5.5 ohm resistor, because they are in series connection. So the current through the 5.5 ohm resistor is equals to the total current, that is I total, and we know that from Ohm's law, current will be voltage over resistance. So the total current is equals to the total voltage over the total resistance, or the effective resistance. So because we are given the total voltage, which was 4 ohm, we'll just take 4, that is 4 volts. We'll simply take 4 volts divided by the total resistance through the circuit, which is the same as the effective resistance, is just 8 ohms. So 4 divided by 8 will simply give us the total current through the source, or the total current from the battery. And we have said that the total current from the battery is equals to the current through the 5.5 ohm resistor, because it was in series connection with the battery or the source. Therefore, the current through 5.5 ohm resistor is just 4 over 8, which gives us 0.5 amperes. So the current through the 5.5 ohm resistor is 0.5 amperes. Now, so the question wants us to find the current through the 5.5 ohm resistor. So that is the answer, 0.5 amperes. Then part C, they want us to find the current through the 4 ohm resistor. The current through the 4 ohm resistor. So remember, this is our 4 ohm resistor, which we combined with the 1 ohm resistor to get a 5 ohm resistor. Then we combined 5 and 5 ohm resistor to give us a 2.5 ohm resistor. So if we want to find the current, we must have two things. One, we must have the resistance through the 4 ohm resistor. We must also have the voltage through the 4 ohm resistor. Of course, resistance is given, which is just 4 ohm. So our task is to find the voltage through the 4 ohm resistor. So we cannot find the voltage through the 4 ohm resistor without finding the voltage through the 2.5 ohm resistor. Because remember, 2.5 ohm resistor is a combination of all these. That is the 4 ohm, 1 ohm, 2 ohm, and 3 ohm. So first of all, let's find the voltage through the 2.5 ohm resistor, because it will help us to find the current through the 4 ohm resistor. Now from this connection here, you can see that the 2.5 ohm resistor and the 1.5 ohm resistor are actually in series connection. And we said that for any series connection, the voltage V total must be equal to the sum of the voltage drops across each component. So for series connection, V total is equal to V1 plus V2. So that simply means that if we want to find the total voltage through the 2.5, we must have the voltage through 5.5, so that we just subtract from the 4 ohm resistor. And because we already have the current through the 5.5 ohm resistor, it is easier for us to find the voltage through the 5.5 ohm resistor. Of course, from Ohm's law, voltage is equal to current times resistance. So the current through the 5.5 ohm resistor, we have already computed it here in part B, which is 0.5 amperes times the resistance through 5.5 ohm resistor, of course, is 5.5. So 0.5 times 5.5 will get a voltage of 2.75 volts. So this is the voltage through the 5.5 ohm resistor. Now, because 5.5 ohm resistor and 2.5 ohm resistor are in series, it means that if you take the voltage through the 2.5 plus the voltage through the 5.5, it must give you the total voltage, or the voltage of the source, because 2.5 and 5.5 are in series connection. So for series connection, V total is equal to V1 plus V2. So because of that fact, it will help us to find the voltage through the 2.5, because you already have the voltage through the 5.5 ohm resistor, which is 2.75 volts. So V total must be equal to the voltage through 2.5 plus the voltage through 5.5. Yeah, so the voltage through 2.5 and 5.5 must give us the V total, because they are in series connection. And we have the V total, we are given the total voltage is actually 4 ohm, or from this diagram is 4 ohm, must be equal to the voltage through 2.5 plus the voltage through 5.5. So the voltage through 2.5 we don't have, but the voltage through 5.5 we have already found it here as 2.75 volts. So 4 volts is equals to voltage through 2.5 plus 2.75 volts. So if I make voltage through 2.5 ohm to be the subject of the formula, I'll simply take 2.75 towards the left hand side, so that I have 4 minus 2.75 being equal to the voltage through 2.5 ohm resistor. Therefore, voltage through 2.5 ohm resistor is equals to 4 minus 2.75, you just get 1.25 volts. So that is the voltage through my 2.5 ohm resistor. Now remember that the voltage through 2.5 ohm resistor, that voltage, the 2.5 ohm resistor, is actually a combination of 5 ohm resistor and the 5 ohm resistor. And because 5 and 5 ohm resistor were in parallel connection, it simply means that the voltage that is entering this junction, so the voltage that is entering this junction must be shared equally, or the voltage that is entering this junction is equals to the voltage through the 5 ohm resistor and the voltage through the 5 ohm resistor, because 5 and 5 are in parallel connection. Remember here, if we are dealing with any parallel connection, then the total voltage entering a junction is equals to the voltage through each of the resistors or through each of the component. And because the voltage through the 2.5 ohm resistor is actually, the 2.5 is the one that is representing the voltage that is entering this junction, because the that is 1.25 volts is representing the voltage that has remained after some voltage has dropped at the 5.5 ohm resistor. So the remaining voltage is the one that goes through the 2.5, which is the same as the voltage that goes through the 5 ohm resistor and the 5 ohm resistor. Therefore, the voltage entering this junction is the voltage through the 2.5 ohm resistor, and because the 5 ohm resistor and the 5 ohm resistor are in parallel connection, V total is equals to V1 is equals to V2. Therefore, we'll say that the voltage through the 2.5 ohm resistor must be equal to the voltage through the 5 ohm resistor and the voltage through the 5 ohm resistor. The reason being they are in parallel connection. They are in parallel connection. So the voltage entering this particular junction, which is the voltage through the 2.5, is equals to the voltage through the 5 and the 5 ohm resistor. So we'll conclude by saying that the voltage through the 2.5 ohm resistor, that is the voltage that remained here, is equals to the voltage through the 5 ohm resistor and the voltage through the other 5 ohm resistor. The reason being they are in parallel connection, and for parallel connection we have shown that V total is equals to V1 is equals to V2. Now voltage through 2.5 is equals to voltage through 5 ohm resistor, which is equals to 1.25 volts. Now once we have the voltage, we can easily find the current. Remember, the aim is to find the current through the 4 ohm resistor. So because we have the voltage for through the 5 ohm resistor and we have the resistance through the 5 ohm resistor, we can easily find the current through the 5 ohm resistor. We'll see why we are finding the current. So from Ohm's law, V is equals to IR. Therefore, the voltage through 5 ohm resistor is equals to the current through 5 ohm resistor times resistance through the 5 ohm resistor. So voltage through the 5 ohm resistor is equals to the voltage through the 2.5, which was 1.25 volts. Therefore, 1.25 volts is equals to the current through the 5 ohm resistor times the resistance through the 5 ohm resistor, of course, which is 5. So if I make current through the 5 ohm resistor subject of the formula, I'll simply divide both sides by 5. Therefore, the current through the 5 ohm resistor is equals to the voltage divided by the resistance. So the voltage is 1.25, resistance is 5. So 1.25 divided by 5, you'll simply get 0.25 amperes. Now remember, this is now the current through the 5 ohm resistor, this particular 5 ohm resistor. And again, the question wants us to find the current through the 4 ohm resistor. Remember that the 5 ohm resistor was a combination of 4 ohm resistor and the 1 ohm resistor. And because 4 ohm resistor and 1 ohm resistor were in series, it means that the current that is entering this upper junction must be equal to the current through the 4 ohm resistor and the current through the 1 ohm resistor. The reason being they are in series connection. Remember, for series connection, I total, the current entering a junction, must be equal to the current across each component or across each resistor. Therefore, the current that is entering this upper junction here, which is the current through the 5 ohm resistor, must be equal to the current through the 4 ohm resistor and the current through the 1 ohm resistor. The reason being the 4 and the 1 ohm resistor are actually in series connection, and for series connection, I total is equals to I1 is equals to I2. Therefore, the current through the 5 ohm resistor is equals to the current through the 4 ohm resistor and the current through the 1 ohm resistor, courtesy of this particular relationship here. So we'll conclude and say the current through the 4 ohm resistor is equals to the current through the 1 ohm resistor as shown here, which is equals to the current through the 5 ohm resistor. The reason being 4 and 1 ohm resistor are in series connection. Therefore, the current that is entering that junction, this junction here, must be equal to the current across each resistor that is in series, courtesy of this relationship here. So the current through 4 ohm resistor is equals to current through 1 ohm resistor is equals to current through the 5 ohm resistor, and we had already computed current through 5 ohm resistor, which was 0.25 amperes. Therefore, the current through the 4 ohm resistor is equals to 0.25 amperes. The reason being the current is the same because they were in series connection. They were in series connection. I have an exercise here which I recommend you should try at your own free time to gauge whether you have understood the example that we have just done. Of course, if you have any challenges in tackling any of the question, feel free to drop a comment specifying the question that you'll need help in. So we've come to the end of our class today, but we need to discuss the quote of the day. The quote of the day stated that the willingness to do something ends up creating the ability to do that particular thing. So the quote is reminding us that we cannot achieve anything significant in life if we don't start by creating an interest in that particular thing. For example, if you desire to be a great footballer, then you must start by creating an interest in attending regular football training sessions. Similarly, if you desire to be a great person in the world, then you must start by developing your character, because character development is one of the key components that defines great people in the world. And lastly, recall that every dream that has been achieved in the world today started with just a single step of faith. Therefore, believe in your journey and trust the process. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you will get notified. Also, if you know any student that you honestly think could benefit from this content, kindly share my link to them. This is Kind Tuition Academy. Until next time.